Hi, welcome back in our discussion about variation. Remember what we introduced in the previous video? We defined what variation is, and we had to take a step by just introducing ourselves into the first type of variation, that's direct variation. So the whole story about it, we discussed it. If you can't follow anything, can you go back and revisit the video? For especially those who are just joining us, you can use the link down here. Right, so now what we are going to do here in this video, we are just going now to solve problems, try to practice what we have discussed about the direct variation. We mentioned two things there. So some like now, okay, this is what we know. How do we use this knowledge now to work out problems in the variation process? Right, so here we have some examples, but before that, let me just try to say something about the direct. Here we are looking at those quantities when one quantity changes, the same by increasing, the other quantity also changes in this similar way. It also increases. When one decreases, the other also decreases. In due course, there is always a constant that is controlling the two quantities. Like say when X changes, Y also changes, there is always a constant and usually represented by a letter K that is controlling the two quantities, which means without the constant, these two quantities cannot exist. So just like now, a constant here is the main controller of the quantities in the change. Right. This will be on every time we're discussing about any type of variation. We always have to consider the constant. And we first of all have to find out what the constant that is controlling the X and a variable Y, any kind of these two variables, like representing another quantity. Like, so a constant must always be there that controls the change between any two variables or any other quantities. So that is when X increases, Y increases. But the constant is there to determine if you'd like to find the value of any one of them. Right, so which is the must to know the constant first before you continue working out the value of one quantity given the other. Like in this example that I have here, we are simply just asked to work out on two issues. Can you take note of this example? One, they say if P let's say varies Q and P is equal to 80 when Q is equal to 2. They're asking us to find one, the constant of proportionality to the equation of proportionality. Right. So that's it that we have here. If P, here there's a symbol, by what I introduced it to you, you should be in the position to understand the meaning of this. This means P varies as Q. But now look at the presentation of the what? Of the relationship. By what I introduced in the previous video, in that example we had about the change in chairs versus the change in legs. I presented something like this one. Just more like a linear equation of some kind. There are no fractions there. So you should be able to describe this one as if P varies directly as Q. That's the way this one is presented, and you can read it out. If P varies directly as Q, and we are told that and P is 8 when Q is 2. It's just like when Q is 2, P is 8. Like when the number of legs is maybe 16, you'll be able to have, let's say, number of chairs is 4. So here we're asked now, what is the constant that is controlling the variation that is there between P and a Q? Remember I mentioned that the constant is paramount in this case. It's the controller of everything. Without it, we don't have to talk about the what? Changes between the two quantities. So we are there to work out that one and fix this one in your brain. It will be there for all the variations. Thereafter, here we are asked to work out the equation of proportionality, an equation that is bridging the two quantities. This is just like an equation that brings out the proportionality. If one changes, the other one changes. Without this one, it means we cannot calculate the any one of them. Or say a equation that you can use to work out the changes. If maybe P changes, how do you work out the value of a Q? Because when P changes, Q also changes. So that can only be done by use of a certain equation, and that equation is known as the proportionality equation. So these two situations are very important every time we discuss the variation. Now, let us work up the constant where P and Q are changing. Right, so the student, what you could do, bring this analyzation that is there between P and Q. You write here to say P varies as Q, like that. You have given that statement, P varies as Q. But now, in attempt to work out the value of a P or a Q, here there's need for an equation. And that equation must be produced here. And you call that equation as a proportionality equation. But in this case, it will be incomplete. It will be complete only when you have the value exact of the constant. So what I'll do here, I'll just write an incomplete proportionality equation, which will be complete at the very end when I'll be working out problem number 2. So this is the relationship. Now, if I want to find P or a Q, I have to have the equation which will be, by what we've discussed in the previous video, it means P will be equal to K times a Q. Right. When I write this equation, linear equation, just know for sure this is the proportionality equation that is used to work out the quantities in the direct variation. So you'll be asking, now you have introduced a K. What is K? Because K is not mentioned in this problem. It's not anywhere. Right, so a K here is a constant, because I said you cannot just talk of P and a Q in existence without a constant. No. So here I've now introduced a K. Means if I want to have P or a Q, K must be there, a constant. So what should I do here? I'll open bracket and define what K is. So I'll write here K. I'll write here to say where K is a constant. Right, a constant here is paramount. So now, let us now find the value of K immediately, and we have to know what the value of K that is controlling P and Q in this case. Right, so to do that, you should be first of all to know the value of the quantities under discussion. What is the value of P? What is the value of Q? To say if P is there and Q is there, then definitely within that, it means K must be within, and you can take it out. Right, so like here, we are told that the value of P is what? 8. When Q is a 2. So you come and write, say, when P is 8 and Q is 2, the places of the two quantities in values will be there determined by a value K. So let us scoop out K and know it. So what you do, where this P substitute for 8 and where this Q substitute for 2. So what are we going to have? It means an A and P, I'll write 8, which is equal to a K multiplied by what? A 2. So you multiply this one by a 2. So you have here 8 is equal to 2K, like that. So that's what we do. To find the constant K, you divide by 2, you divide by 2, and at the very end, what are you going to have? You find that we have got a constant there, which is equal to what? A 4. Right. So it means here, in this process of the change between Q and P, this one is determined by a constant K, which is equal to 4. Right. So now, number 2, we are asked to come up with the proportionality equation. Right, remember what I've said. A proportionality equation is just this one here. It's a linear equation, P is equal to K, Q. And we know how this linear equation is coming about. I gave you a good example. Right, so this is the proportionality equation. Only that here it is not complete, it's incomplete. Why? We don't know exactly the value of the K. So this time that now we know the value of a constant, then we are there now to make this one complete, such that we are going to respond to this question by saying, therefore, the proportionality equation will be what? Just take this same equation, but substitute for K. So here it means our proportionality equation will be equal to P is equal to, instead of having a K, you write a 4, that to be multiplied by Q, it now be 4Q. So P is equal to 4Q is the proportionality equation. And every time if you know P, it means you can find the value of Q. You just substitute for P. If you're given the value of a Q, then you'll be in the position to find the value of P, because you just multiply 4 times the value of Q which you are given. So it goes like that. Right. So this is very important. A K is also very important. So please, students, let's get to know, first of all, the value of the constancy and also the value of the what? Not necessarily the value in this case, but the nature of the proportionality equation that will always be there to be used in working out the values of the quantities. Right, so having known how to calculate the constant and coming up with the proportionality equation, let us go now into another problem where now we are asked to work out a value of a certain quantity. Right, number 2. They tell us say Y values directly as X and Y is 24 when X is equal to 6. Find Y when X is 8. Right. You can see now the logic that we're using here. We are first of all know the direct variation, the talk of the relationship, talk of the equation, talk of the constant. Little by little now here we know how to calculate the what? One of the quantities now in the relationship. So Y varies directly as X and Y is 24 and X is 6. Find Y when X is 8. What would be the value of Y when X is 8? So by what we have just been introduced in the first example, we know the procedures on how best we can work out the value of the missing variable, which is Y. It means the first thing you do all what we just did earlier. Find the constant, then find the proportionality equation. Like so here we are. You're going to bring the relationship between Y and X in brief. Y varies directly as X. So here you're going just to write briefly to say Y varies directly as X. In attempt to find the value of Y or X, you need to produce an equation. So you say if I need to find Y or X, it means Y should be equal to K times X. Right. So this is your proportionality equation. Tell us about the K. So you tell us that say where K is constant. Don't forget that. Right. Then now let's find the value of K. So that can be found when we know the value of the quantity Y and the value of the quantity X. So here you come and write say when Y is equal to Y is equal to 24 and X is equal to 6, you substitute these two values for Y and X in this equation. So you write where there is Y, you write a 24 and is equal to here there is k times x, it means 6 times what? Times k. Right? Find the value of k, divided by 6, divided by 6, then there here you have got to k as a 4. 6 times 4, that's 24. So it means the constant here is a 4. Right, then from there, what is that we're going to do? You are there now, first of all, going to give us the proportionality equation that bridges up x and y. You'd say now, therefore, proportionality equation will be this one, and light y is equal to, where the scale light 4 times x. That's the proportionality equation. Now, what is this that we want to do? Let's find the value of y when x is 8. So it means you are going to use this proportionality equation to find the value of y when 8 is the value of x. So what do? You write it, say now, when x is equal to 8, therefore, what? Bring the proportionality equation down here. Y is equal to 4x. It means wherever you have the value of x, that x has to be substituted for 8. So here we have y equal to 4 times the x is represented by 8. It means 4 times 8. As such, our y is equal to what? 32. We'll find the value of y. Look at the stages that we have just done. Right, so that's the way it is. Lastly, can we now have the applied problem that is now in the realistic life situation? So here we have known how to handle issues about the direct variation. Let's now apply the knowledge into the real life situation. So with me, I have another problem here that we need to work together. Application of what we have just so far done. Do you have 5 types of scenarios in life, and we find ourselves using the knowledge about the direct variation. Right. So let us look at this one together. Light. All right. Here we have a problem. Some of us already there. It's more like issues about physics. Right. We are told that the resistance to motion in the air varies directly as the square of the speed of the object traveling through it. If the bullet is traveling at 360 kilometers per hour when the air resistance is 2,000 newtons, find the air resistance when an object is traveling at 600 kilometers per hour. You can see now, just by the nature of the problem itself, you're already there that we're already in what? Physics. So maths to physics. And more importantly, this problem is a real life situation. An object is traveling. We're trying now to calculate that is the a resistance to motion. In this case, talk of a bullet. So I want to apply what we've just learned in the direct into a real life situation and in other sectors of knowledge, that is physics. Right. So if you have followed everything that we've just done in the 2 previous videos, you'll be able to see that here there's nothing as a problem. Things are just straightforward. So you just have to remember what we've been doing. We had some quantities represented by variables. So what you do here, the first thing is you have to at least pick the quantities which are under discussion. You talk of the quantities which are related here, which are in relationship with each other, then work on them as we have done in the previous talk of what? Discussion. Previous video and the video that we are just in here, where we have just looked at the first example. You see that what we have done in the first example and what we've discussed in the that very first video, you find that this one will not give you some kind of what? Hiccups. So if you can study this one very well, you find that here we'll be talking about the resistance to motion versus the speed of an object. In this case, it's a bullet. So what we do here, you at least try how to represent these two constants, these two quantities by a particular variable. Like say here, you'd say, let the resistance be represented by a variable, maybe what? Capital R or whatever variable you can use. And the talk of the speed be represented by a variable what? S, as such. So that you have to fit what you know about the variation. So the resistance to motion of the air, okay, in the air varies directly. R square of the speed. So if you are going to summarize the two presentation of R and S, it will be like R varies directly as S. But now talk of the square of S, it means you are going to square the S like that. So it means resistance varies directly as the square of S. So once we have presented this one down, it means the whole story of what we have already done and known about the direct variation has to be presented here. Right. What it is, first, bring down the what? The proportionality equation. So you say now therefore your R is equal to a constant multiplied by S squared. Where you know in this case your K is what? Constant. Like that. We would like to find the value of the what? A resistance. When the speed is 600 kilometers. So first, let us find the value of a constant. That is associating the variable R and S. So what you do, you check the value of R. If it is given and S is given, then the K is going to be found. So here you are told that say R, which is the resistance, is 200 newtons, right? So here you write now when R is equal to talk of 2000 newtons, and the speed is found to be 360 kilometers per hour. So it means the speed is 360. So it's more like when R is 2000, S is 360. So you substitute wherever this R, will write 2000. Here it will be K multiplied by 360 squared. So if you simplify this, you're going to obtain that is 2000 equal to K multiplied by that, you have that is 129, that is 600K. Then divide both sides by the coefficient of K, which is 129 600 into 2000 in order to find the value of K. So I divide 129 600. This side again, I also divide 129 600 like that. So at the end, what do I obtain? I'll find that say this gets into 129 gets into 129 600 gets into 2000, a decimal value, which is K equal to 0.0154. Right, you can at least cross-check this one if you can use a calculator, because there are bigger values getting into a smaller value, you have at least a decimal number like that one. So I think in this relationship, you should be in the position to describe the constant of proportionality is 0.0154. Having done that, let us now come up with a complete proportionality equation, which is just to be depicted from here, a proportionality equation. But this one doesn't have a K. So the moment now we have found the value of a K, it means our proportionality equation that is complete is equal to R equal to, where this K will write 0.0154, then AC squared, proportionality equation. And it's the one that we use to find the talk of the resistance when the object is traveling at 600 kilometers per hour. So here we are going to use this proportionality equation to say, like, when speed s is 600, what will be the value of r? So what you do here, you just substitute for this s like this. So you have got your r is equal to 0.0154 multiplied by 600 squared. So if you simplify this, you have your resistance as what? You will have it as 19,440 newtons. Right, so resistance will be 19,440 newtons, while the speed then it will be 600 kilometers per hour. Right, so the whole process that we have used here to work out the value of the missing item is the whole knowledge we have just learned in the direct variation. Right, so I think be able to appreciate that the knowledge here about variation can also be made in the real life situation and also in other sectors of knowledge like physics. You can also have it in what chemistry and other areas of concern. Right, at this moment in time, I think we have talked enough about the direct, and that's the end of it. In the next video, we are going to be introduced into the what? Inverse variation. Thank you very much for being together.